Good morning, everybody. Let's just wait a few more minutes for all our registrants to pour in, and we will get started momentarily.
All right, thank you, Michael, and thanks everybody for joining today. Obviously, interesting times with the pandemic going on, and a little technical, presentation here or there is hopefully helping pass the time and then help us all become a little more educated. So, Michael and I were talking earlier that we're reviewing their website where they link all the videos to the past webinars. So it's a real nice library. Everybody should be aware of to go back and check out. So I've took the time yesterday to look at 2 or 3 of them. They're all pretty good. So so let's get started here. Today we're going to talk about, as Michael mentioned, removing personnel from arc flash hazards. And specifically kind of the application of remote racking and even more specific universal remote racking. And to kind of start that, an overview here where, talk a little about, who's Inolect, who am I, why are we kind of qualified to discuss this, and lead you through a conversation on incident energy and remote racking and mitigation techniques for arc flash. Talk about risk assessment and really show you some got several pretty good pictures here of specific breaker applications. Maybe you've seen, maybe you have some of these breakers, but we can kind of go through, and if you have a breaker we don't mention, throw it into the chat, and if you have a specific question about applications like that, we'd be happy to try to take them during this presentation or even at the end. And if we need to, schedule a one-on-one kind of virtual presentation with you if that's something you're interested in. So, who's Inolect? Well, Inolect is a power system consultant engineering firm that also has electrical field service, maintenance and testing capability, and then we have a manufacturing arm of our business that manufactures a universal racking system called the Inolect. It's been around in some shape or form for about 20 years now. The inventor of it is kind of credited with being the godfather of remote racking, developing the very first system commercially available. So we've been doing this a while. We manufacture out of the U.S., out of Baton Rouge, Louisiana, where our home office is, and we also support the product from that office as well. So, our mission as a company, whether we're doing engineering, electrical field service, making sure equipment's reliable for customers, or supplying something to get them, remote from the hazards, is always safety and reliability. There's an obvious safety implication when you're talking about arc flash and incident energy. The reliability piece, maybe not so much, but we're going to talk about that today. How do we hook a rotary motor mechanism and drive a racking screw and get a breaker racked in and out safely, but also focus on not damaging that breaker. That's the reliability piece. So that's kind of who we are. I've been with Inolect 13 years now. I have to do some math. It's been a while, but been here a while, and done some engineering projects when I first got out of school, for Inolect, and then been doing the remote racking as a kind of regional business developer. I cover mainly the eastern U.S. for us. We have another guy out of Vegas that covers the West, but so it's been out there, seen a lot of breakers. We do a lot of on-site demonstrations, obviously prior to the COVID thing where we could get access to, sites and customers. And hopefully that all gets back to normal soon enough and we can get out and see some of you all. But that's kind of our history, who we are. And then, a little history on the Inolect further, right? This is, we call it the Inolect 3 today is what we offer. We also offer some medium voltage starter switching type products. We call them ISO-rack and I-90 product families. But the main kind of marquee product is racking low and medium voltage circuit breakers with the Inolect, and this is just some examples of what we've built over the years. And kind of the modifications that happen. Here, like across the top, a lot of these devices are they're a fixed height, maybe chest high, right? To rack a very specific breaker type and not necessarily universal. And then you see, all across the bottom, there's an elevating mast to our product that, we can do a screw, 2 inches off the floor to, 80 plus inches high, right? So, 10 years ago, when there was a big push doing studies, it became kind of a, hey, let's not just worry about maybe specific breakers. Let's go into this universal conversation. And, we're doing studies down into the 480 volt and lower voltage levels, which, at the onset, a lot of people thought maybe there's not as much hazard there, but come to find out, lower voltage, higher current, you have maybe some larger incident energy values there to worry about. So, following the market and the needs of our customers, we had to kind of modify this thing and make it where we could get some different vertical heights, right, to connect to all sorts of racking screws. And, today we're racking, I don't know, we have over 200, 250 accessories to connect to different breakers, and we're going to show some pictures of those later. But it's, we try to have one product that you can train your people on, implement it very easily and quickly out into the field and get people away from racking these breakers. So, incident energy, arc flash, most of us probably familiar, have heard of it, but it's, basically a dangerous condition that occurs, and there's usually electrical arc involved. It can be pretty dynamic. Usually when we're talking about incident energy, we're talking about calories per centimeter square, which is a heat value. But there's lots of other things that also come along with if a breaker has an arc flash event. And we'll look at a few of those here in a second. But possible causes, human error, improper installation, wear and tear on equipment. I think lack of maintenance is probably one of the biggest ones that we see and hear about when people have equipment failures. Let's see. Next. The hazards with the arc flash itself. So, intense light. A lot of the suits, the arc flash suits that are offered today have lenses, dark lenses and things to help with light. Very high temperatures, the molten copper. Speaking with a guy about a week ago about a facility he worked in where a guy had breathed in the molten copper and some of the many ramifications of that, burn unit and rehab and trying to get that guy back healthy, and very, very sort of dangerous hazard. And there's no ounces of molten copper on an arc flash label on a switchgear typically, right? We're focused on that, on the heat energy generated in calories. But all these hazards, if we're looking at incident energy, really need to be assessed and thought about. And it's one of the nice things about something like remote racking is, if you're remote to all of those hazards, well, you've just mitigated, most of them, right? Sound, shrapnel, the whole deal. There's some statistics here, which I think are important. Again, we have the ability, there's a PDF download of the presentation. So anybody who, may be interested in remote racking or bringing this up where you work, to the staff or operations people that are affected by it, we like to have a few statistics in our information, so you can, bring that back as well. So, 80% of electrical related accidents and fatalities involve qualified workers, right? Folks that should know their equipment, be trained on it, on the operation and maintenance of it, oftentimes. But there's still a lot of fines here listed, and a lot of dollars, whether it's medical expenses, lost time, lost productivity, could be loss of, making whatever widget that that facility happens to make as well. Usually when there's one of these incidents, there's a a catastrophic kind of failure, of the switchgear or the breaker, right, which has to be repaired, replaced. So, there's a big impact with this, and I think it's fairly obvious when you see the videos and, some of the information that's out there on it. I know most of our customers, they're getting yearly either 70E from, FPA training or, some type of arc flash, information that they do on a yearly or biannual basis. So I feel like our industry is stepping up and trying to get the bull by the horns and do something about it, which is great. And then there's a risk assessment conversation. Is okay, we have this arc flash. What do we do about it? And ever since 70E, the 2018 version, which I believe is the latest, there's been a lot of terminology change and move over into a instead of trying to go directly to an application of, okay, I have a breaker, how do I safely deal with it? It's more of a, okay, we need to step back and say, okay, racking the breaker, voltage testing, all the electrical work tasks that we have to do to interact with the equipment. What is the real risk associated with doing those tasks and trying to get them done safely? Now there's lots of discussion about, electrical safe condition, getting equipment into that status. Sometimes it's very difficult. Some of the breakers, they say you have to have the door closed. Well, by the nature of the design from the original OEM, there's holes in the door, right? And so there's a lot of interesting discussion over the years about, doors closed and open, different things. What I would encourage you to do is, if you look back at, the last 5 revisions of 70E, right, which is trying to help us do, best work practice around electrical equipment, what you'll see is that insertion and removal of power circuit breakers has always been pushed to, full suit, right? Full arc flash suit or high risk categories. That's never relaxed through any of the conversations about, doors open and close and different things like that. So I think there's kind of a consensus out there that, when you're racking a breaker, it's not exactly a normal task. Like tripping and closing or doing some of the other things, charging springs or something. And so that, we definitely want to put protections in place and protective measures. How do we do that? Well, thankfully we have a kind of philosophy path here, which is the hierarchy of controls, right? So, the thing that I'll mention about this is, PPE is kind of the last resort here. It's at the bottom of the solution, chart. And it's, again, the way this graphic works, right? The further you are toward the bottom, the less effective you are. And I think that, specifically with regard to racking circuit breakers and incident energy, if you're in front of a breaker within 2 or 3 feet where you have a manual racking tool in your hands, all of those hazards we mentioned earlier about light and sound, molten copper, right? Even before we get to the heat, which is what typically your PPE is picked out based on, an energy level. All those other considerations have to be, looked at as well. So, what we're trying to do here is say, okay, let's go to the higher controls and figure out, okay, what can we do to address, incident energy? And so we have this slide here that kind of talks about, well, when you have a problem or a hazard, typically good engineering practice is to kind of simplify that or break it down into some smaller pieces that you can, modify or adjust or redesign around. And so we kind of have 3 pieces to arc flash, right? We have the fault current available in the system at the point which we're going to be working. We have the distance to that equipment affects the energy exposure, right? If I'm very, very close to an energy source, I have typically a high, value, and if I, back way away from it, I drop that value significantly, and it's usually an exponential type rate. And then, you can reduce fault clearing time as well. So the fault clearing time is typically doing something to the protection schemes, trying to trip faster. And so, at Inolect, we have solutions that, whether it's remote racking for the working distance or the protection piece, We're typically in and around these conversations on a daily basis, helping customers decide what the best solutions are, and it's kind of the next piece here. So we have a product that we roll out from our engineering group, that's a remediation analysis, and it looks at, hey, here's all my buses. I've done an arc flash study, and I don't like some of the results. What do I do? And we've tried to come up with what we feel like is a fairly objective approach to addressing the conversation. And again, it's the, here's my buses, here's my existing arc flash level, and everything else across the top of this table are mitigation techniques that manipulate one or more of those values, right? The distance to the equipment, the fault current available, or the trip time, from a protection standpoint. And you can see, remote racking, this particular bus, top 105 cals, back down to under 1, right? And it doesn't. If you look in our report, there's typically some fairly simplified English definitions of all these solutions, but there's also pros and cons, because we've seen facilities where maybe a maintenance switch, right, is a great solution, and then we've seen some where it's not because of either coordination issues or age of equipment, different reasons. So what our goal is to always kind of educate the end user about what their options are, and give them as many options as we can with regard to incident energy and the solutions around it. There's also a conversation about the practicality of implementing a mitigation technique. It's real easy to say, hey, go implement something like a bus differential, but versus say remote racking. And there's conversations you can have there, and some of it is when we get into projects and actually do an implementation, there's a duration of an engineering project. Could be 2 weeks, could be 6 months or a year, depending on the schemes and the complexity of the the project. You have the hardware, and the protection side, relaying, wiring, all the things that have to happen. You gotta have all of it documented, engineered properly. You got to have it installed, so there's outage time possibly. So you have on manipulating the time piece of this conversation, there's definitely some pieces that have to be put out there, and they're all very doable, and of course we recommend them. But the nice thing about remote racking is, as a short-term solution, right? In 4 to 6 weeks, you can typically get a racking unit on order, get it out to the field, have it commissioned, and it's up and running. And you've realized the energy reduction that distance increase is giving you. So that's a really nice benefit, and some little piece about our philosophy, looking at a facility, lots of different buses, high energies, low energies, and every customer we work for kind of has a different requirement. Some people want to get below the 40 calorie mark. Some people say 8. So we kind of tailor these solutions to whatever the needs of the end user is, because they're all very different. Michael, here we had the first poll question.
So I'll put the poll question up. We'll leave that up for about 60 seconds. Maybe you guys can answer that one. And just trying to get a quick poll of, has your organization been through an incident energy, what we used to call arc flash mitigation process? Okay, we're going to go ahead and close that one. Back to you, Brian.
All right, thanks, Michael. All right, so talked about the philosophy, kind of our generalized approach, which includes more than remote racking. Now I want to kind of zone in on remote racking and kind of the application. It's and just to start, kind of the before and after here. When we when we were prior to remote racking being commercially available, this is how we did it on the left, right? We would, and even before these suits were available, you'd be a little less dressed out. But this is kind of what's going on, before and after. The work distance on medium voltage switchgear, like the picture here with the before shows, is 36 inches. So and this happens to be an arc resistant lineup of gear, but this particular operator electrician, something happens here. He's definitely in the line of fire with or without the PPE on. And it's important to remember that the PPE, as it is on that hierarchy of controls list, kind of the last line of resort. One of the reasons is that, like, it has a design criteria. If this was a 40 cal suit, even if you saw a 40 cal exposure, there's a usually disclaimers on the tags of these types of garments that state something to the effect of, that at the rated value, you still can see up to a 2nd degree burn, which is most places potentially a recordable injury, and not something anybody wants on their records or to have their people go through. And so as a mitigation technique, we're simply saying, okay, let's go from 36 inches or 2 feet away on low voltage gear to more like the gentleman on the right, where he's got significant distance between himself and the breaker, or any kind of arc flash incident that may happen. Sometimes we have line of sight. Sometimes we rack and door closed, sometimes we rack door open. There's lots of variables. Sometimes the gear gives us no options, or very limited options on the whole door open, door closed, just based on its design. We're racking switchgear in facilities that can be, 1920s, 30s, 40s model switchgear. It's kind of amazing in some respect that it still functions properly, and it's robust enough to be lasted this long. But and then we're also, this is pretty much brand new gear here, put in a few years ago. One of our local customers, but this is, simple extension. This particular breaker is a very straightforward just socket to connect to it. There's no real interlocks to satisfy that have to be addressed by any additional accessories from our equipment. But it's kind of the basic overview, right? Get some distance between the operator and the breaker. Now I wanted to just show a few applications. This is Eaton's VCPW. It's a very popular medium voltage breaker. We see quite a few of these in the field. Eaton, GE, the power vac that they have, the Powell, which is actually the breaker on the prior photo. There's a lot of modern vacuum breakers that they're very basic. Again, this is actually the same tooling that it took to rack the Powell vac. The interesting thing about this particular breaker is there's a plate where when you put the socket onto this racking screw, there's some spring pressure that's pushing out against that socket. And when you're doing this by hand, right, you naturally connect the tooling and lean into the racking screw, to put pressure and turn the crank. When we're doing this with the Inolect system, we have a set of springs on the back of our motor that keep horizontal pressure, so we can defeat these, what I call passive interlocks. So that's a big key kind of element to a universal racking system. If we don't have something that needs to be, that's spring loaded, that we're trying to push out of the way, at a minimum for every breaker, those springs are helping me stay engaged with my tools, right? We got some forward pressure there to do that. Again, you could rack this breaker door open, door closed. In this case, I think we were setting up to shoot some videos for marketing purposes. So we did some, it's a little nicer to see the door open. We had a dead bus to do it, thankfully. But you can see the movement of the breaker, where with the door closed, you don't see a lot of that. So it's a little better for the promotional standpoint. And again, this will do, single high, two high operation. Another application that a lot of plants have are these vertical lift, the old GE Magna Blast breakers. Again, we're not modifying anything. We're just clipping in an adapter that we manufacture that mimics the old racking motor. And then we can just simply use a slotted stainless tube, right, to connect to this roll pin on the end of the mechanism. But these are, there's a big install base of these Magna Blasts back in the 60s kind of time frame. And with our breaker shop, we rebuild them. They are built like tanks, and they're about as heavy as a tank too. But they're notorious for having some issues with the vertical lifts. Like a lot of times when they lift, the shutters won't open, and so the stabs of the breaker, instead of clearing and being seated into the bus work, they'll just completely wreck the stab or the shutter mechanism and the tin and everything. They also have a tendency to fall off the side of the elevator framework, right? So they'll tilt in the cubicle. And one of the really nice things about our racking system is that we can detect changes in torque, right, from what we consider normal to what would be abnormal, right? So an increase in torque by having a breaker tilt in the cell and not running nice and smoothly is typically going to cause our unit to trip and give you the option to maybe rack the breaker, jog the breaker back down or something like that. So this bottom middle picture is actually one of the elevator frames, on I guess the left side of the cell, but this was at a customer site. We actually helped them repair this, but this was done with the old racking motor. It was a real high speed, kind of high torque DC motor. And what happens is when that mechanism, when it lifts the breaker to a certain point in the cell, it tilts a mercury switch in the cubicle that allows the motor to shut off. Well, if the switch doesn't make up, it doesn't turn off, and then you get this sort of scenario sometimes where it starts to bend metal and do damage. So we even have I think a design that is beyond the original OEM solution with the motor. Is that one, we're more a little lesser speed, a little more smooth in the operation that we use for this breaker, but we also we're not trying to detect those mercury switches. We want to run the breaker in all the way to its full stop and see that it's fully seated. We just do it through torque monitoring, not through any kind of contacts or control circuits in the gear. There's a kind of a unique application here. I keep saying no modification. This is actually a modification, but what we're doing here is taking this from a steel metal bar, right, that you stick in the floor and lever this breaker on and off the bus with, to an OEM solution that we can offer to put in a rotary mechanism and a catch block and follower type system that got to mount a little block on the bottom of the breaker, but after that you can close the door and rack this with the door closed. So for anybody that has the old Alice Chalmers or Siemens Alice MAs and FCs, which are 5, 15 kV respectively, those are some pretty interesting applications that if your guys are having to suit up and get inside of a 15,000 volt cubicle, on a daily, weekly, monthly basis, racking breakers, a lot of people didn't realize that there is an OEM solution that maintains all the interlocks, and basically you can now rack it with the door closed. This is a major safety improvement for anyone that might have those particular breakers, so I like to show it. The old ABB Gould ITE HK is kind of a unique application. The first solution I showed or application with the Eaton VCPWs, again, I would say 70–80% of the breakers, if not more, kind of work that way. It's just some kind of a socket or a stainless machine piece to connect to the racking screw. These other applications, as you can see, is a little more variety, right? Floor screw modification. That's a breaker that's a vertical lift, and we have to mimic the old motor, that clipped in. This particular one comes in a couple varieties. There's what we call offset, where there's spacing between the racking shaft and interlock, and then there's the non-offset, which is what we see probably 95% of the time. And then if you have panel mounted relaying, you get an extra throat extension on the end of the cubicle. And in that case, we need to make sure, you have these OEM extensions, which help bring the connection point out toward the door and allow us to not reach in as farther. If you're doing it by hand, there's a little slide access window at the bottom of the door, in this gear. So you have to slide that out of the way and then, stick your hands in there. It's much better to stick them in 3 or 4 inches to be able to make this, rack the breaker than it is to stick them in maybe 12 to 15 inches, right, where you're almost up to your elbows. So, I've run across customers that I think these extensions, when they ship the gear, were in a different crate. And so you'll see lots of people who don't have the extensions, but didn't even know they had them in a box somewhere, 30 years ago, 40 years ago when the gear was put in. So, if you have the HKs, we're going to use a actuator to lift the position interlock piece. We're going to, lift it up, turn the racking screw in until we pass the test position, drop this piece back down so the pin can fall back in the hole at connect. And then we kind of reverse that coming the other way. So, if you're thinking, well, I don't have a breaker maybe that is just a simple, socket or just, put a manual tool on a crank, chances are we have a solution for it. We've designed one over the years, just trying to meet the needs of all the various breakers that we see. And then there's a conversation about what we call interlock actuators. So, some of these breakers have tabs and push buttons and different access shutters, windows that have to be slid or moved or pushed. And those particular breakers, this is ABB's pretty much their latest gear, the add back, or even if you have an AM back, which is a little different, I think, operating mech. We have to push this button down to free up the racking screw, again, a lot like the HK in the last photo, where we can get between the disconnect test and connect positions, with the gear and the breaker. So, if you have something that, you have to push like that, chances are we have an actuator that either magnetizes to the door like this one does, and it plugs in back to our racking system, to get control, power and signals. But again, just showing some of the different applications here of, how do we deal with this interlock or that interlock, or, mating up with a particular, breaker. And here, Michael, we had the second pole.
So here's our second poll question. Do any of your organization's facilities have low or medium voltage drawout power circuit breakers? Leave that up about 20 more seconds. Okay, great. Thank you so much.
All right, so I wanted to just have a few more slides here. We'll probably end under the hour for sure, but I wanted to put out some kind of recommended specifications and talk briefly about why some of these are important. If you're looking to do a remote racking project as a mitigation technique for incident energy, there's some options out there. So, one is, this concept of a universal system, right? One system that, if you have one facility with, 10 electricians, or if you've got 50 facilities with, hundreds of operators that may interact with switchgear, if you've got one system that can rack your low voltage breaker and, wheel it down the hall and connect to a medium voltage breaker, we feel like that's a pretty good solution, right? Because you only have to train on one thing, you only have to implement one type of device. If people move between facilities, or job roles, they're familiar with it once, it's going to take less time to get them maybe familiar with it the second time. So the universal concept, again, for us, that's, low voltage 480 volt to about 38 kV. As Michael mentioned, like the drawout circuit breakers. The second thing is this, no switchgear modifications. There are some solutions out there that would require you to, put bolting hardware and modify all the doors of your breakers. We don't have that situation. And a lot of that just has to do with trying to be, I guess, simplistic and just easy to implement. Again, 4 to 6 week lead time on something like what we're doing, and you can be up and running. So, we don't want, time to be an issue on a project. We typically can meet just about any schedule that's needed. So, but not having to modify all those breakers is a big time and cost saver. So then I would say, PLC control. So we run basically an industrial automation system on board our unit. And that's a, PLC. We have a remote, touch panel. That's our pendant for our operator. When we stand away, you can see here the top left photo. We have a couple of varieties of that. The standard one here is a 75 feet of Ethernet cable between the base system and the operator. That gets us out of most arc flash boundaries. If there's if you've got an 80 foot or 90 foot boundary, we can adjust the cable length a little bit. There's also some options to do wireless and get rid of that cable altogether. And we have about a 150, 200 foot line of sight, capability on the wireless piece. And then there's something we've come up just within the last few years. It's a remote operator station where we can actually take an enclosure and go maybe outside the substation and kind of have a very specific location where the operator electrician has to use the equipment from. And this way you're not subject to, hey, let's roll the cord out 10 feet and maybe the arc flash boundary was 15, right? So the human performance aspect of fixing the location of where this remote panel is, we're seeing a lot of the management folks that we deal with really like that concept. So we're, but the PLC, the intelligence we have basically helps us, gives us great feedback to the operator. What's the position of the breaker, which I mentioned, breaker position monitoring. It gives us some real-time torque graphs, right? So I can see the breaker go on and off the bus as it's being racked. When we're losing that 2 or 3 feet distance when we were racking by hand, when we lose that up close tactile feel, we want to give back that capability as best we can, back through the remote. So we track the position of the breaker. So we know, hey, it's about 10% in or about halfway in, fully in. There's a torque management piece where, we don't just elevate the racking torque values allowed to what it takes to get over the stabs and get the breaker on the bus. We actually use 3 settings now. It's a setting on approach, right, to get it back to the stabs, a setting at the stabs, and then we have a third parameter now for when we're racking out, because usually racking out is pretty less strenuous from a torque standpoint. So we felt like if there's people that can get you 25, 50 feet away, but the level at which we're trying to limit torque, right, applied to the racking screw so we can maintain a high level of reliability is really a key. The speed control motor, so one of the unique features here is that the system is going to slow down a few turns before it hits the stop at the end. And that slowing of speed lessens the impulse of it, when it finally hits that stop and doing damage. So many of the, OEM providers today that offer remote racking systems that are just, cheap drill motors to hang on the door, just, kind of, we call it, checking the box, right, of the spec. But a lot of that's bought with new switchgear, and a lot of it is kind of rough on the gear. People are breaking shear pins. We replace quite a few OEM solutions on brand new facilities, because of the, big DC drill motor that's on there, and it's giving it all she's got. I could steal the line from Star Trek. So, we talked about the spring-loaded motor. We talked about and showed some of the interlock devices where we have either position interlocks or racking screw access interlocks that have to be dealt with. The remote trip and close. So actually the bottom here on the close side of the motor, we show a little black tip plunger, a little linear actuator where we can actually, if we're going to go rack a breaker, one of the real key safety considerations before doing that is to trip the breaker to make sure it's open, because we don't want to rack a closed breaker. And so what we've done is, we come up with this, we call it a, push button operator, but from the face of the manual controls on either a medium or low voltage breaker, you can slip the unit in, line it up with a trip button, stand back, 20, 30, 40 feet, whatever distance you need based on your arc flash labels, and you can trip that breaker. Then you can go in and remotely rack it. So again, trying to be universal, the trip and close piece is something that a lot of our customers are finding very useful. I would say, the last part on here, commissioning and training. So, our product is a commission product. And I would say, if you buy remote racking in general, then that, the on-site support and, getting that implemented across your facility or even in one switchgear room or lineup, you want to get some training with that. You do not want, operator in the middle of the night, first time he's ever seen this unit, and he's trying to use it, right? We want to come out with our system and our PLC and the intelligence and tune it to the specific breaker, the site conditions of your breakers, right? A lot of times for a specific manufacturer, make and model of gear, the turn counts on the screws are very similar, right, by design, but the torque requirements can be all over the map. And that's, are you in a coal plant? Are you in a data center? Are you in a carbon black plant where you have soot and things that are, eating at the racking, the mechanical parts on the mechanism, or causing, grease and things on the mechanism to kind of seize up. So, we want to come out and set this thing and train your people. That's always been our approach, and it works really well. So, that's kind of our philosophy. We can come out and give you an intelligence system that knows the position of the breaker. It's monitoring torque. There's ability to have there's a couple of alarms in it, that if somebody does make a mistake or a wrong selection here or there, they can, most likely it's going to stop them from going too far or getting themselves in a really precarious situation. But that's, these is what I consider kind of the specifications I would be looking at, if I were in the market to move forward with something like remote racking. So I wanted to share that as a list again for anybody downloading the presentation. And then I wanted to show, I guess what one of the what I consider one of the key features of the unit, which is, again, when I'm giving up the manual racking by hand, how can I replace that with something? And I think we've done just a really nice job with this torque graph. So this is actually it's an ITEHK, but this is a rack out and then a racking in sequence. And blue is the motor speed. So again, we slow down before we hit a stop at the end. Again, slow down on the way. So this is out, in, and then the green is torque, right? So what you can see here is there's a real high pull off when the finger clusters, right? They're really tight on this particular breaker, and when it's being racked off the bus, it takes a lot to move it. Now, probably a little lubrication on those toolets for this would bring this down quite a bit, but I would say this is probably in the 20-25 foot-pound range. And then, just carrying the weight of the breaker, then you have basically racking it in. This is putting it on the bus, right? And so, when we're dealing with the culture shift that is to implement a safety solution like this, and we're out doing the demonstrations and showing the solution, the people really gravitate to the fact that, okay, like, I don't want to give up my the way I used to do things, right? By hand. But I agree, 50 feet away, I'm way safer if something were to happen. And then they see, okay, well, I'm gaining back through the technology that's offered here. The tactile, what I had in tactile feel, now I have in this feedback that's given to me on the screen. So, this is a little bit older graph. We actually pulled a graph the other day from a newer program revision. So, here we actually, the blue is speed, but we've actually set in the trip values for torque. So you can see here, there's kind of a lesser value on approach and then a higher value here. Now, the green, right, is the actual torque that it took to rack the breaker. And this breaker that happens to be in our shop doesn't have any stabs, in the runbacks. So normally what you'd expect is, slow down, you'd see a spike in the green, the torque here between this like 140 and 70. Then it would kind of settle down and you hit the stop at the end of the cubicle. But because there's no stops to press against, right, you don't see any of this torque response. But this graph is true to that particular racking operation, right, which is what's key is giving you the feedback that you see. One of the other things that's not completely intuitive here, or immediate as maybe or obvious as a benefit, if you're racking a breaker and this green torque line just goes to zero, well, maybe the connection to the breaker has become compromised in some way. I've actually been on demonstrations where some of that's happened, but you can see this actual torque graph is everything's within probably half a foot-pound depending on where it's at in the racking sequence. It's pretty well maintained breaker, like it's doesn't have any big spikes in the middle of the racking screw where they shouldn't be. So again, even there, reliability wise, people are utilizing this as kind of a maintenance tool, right? Looking at the grease may degrade over time, torque requirement would go up. Eventually this torque requirement here gets into this sort of pink purple line, it's going to trip, right? Because this is 3 or 4 foot-pounds and this is 6 or 7. Well, we don't want to allow more than 6 or 7 here because we know that's abnormal. So that's kind of the way the torque monitoring works as well. And from there, I would just kind of recap and say, the risk assessment or the focus on risk assessment with arc flash has been, again, a big push, especially in the latest 70E. We look at a kind of a comprehensive, objective way to mitigate incident energy, looking at lots of different options. And then, of course, we talked about, PPE is a last option, which is a frequent conversation I have where, why are we doing arc flash studies? Why are we doing, incident energy analysis? And, a lot of the answers we get are, well, to select our PPE, right? And it's just I think hopefully today, you saw a few applications on remote racking, saw why, hey, maybe I was going to get into a system like this, something with some technology and intelligence behind it is kind of the way to go. And then, the PPE thing, last option, it's very, very kind of limited, utilization there. And then, with the different applications we've seen, if you were going to, go to a manufacturer and or come to us and look at, for remote racking, one of the things we need is typically photos of the breakers or, breaker information on what you have to kind of put some estimates together. So between that and the kind of the key specifications that I laid out, I think that should help anybody kind of get started, or at least start a conversation if they need to. So I would say this: I appreciate everybody's time again. We made it under the hour, so hopefully everybody get a few minutes back, and and that'll be good. Michael, was that the last poll, or do we have anything else here?
Yeah, there's one or two more polls. So let's go to poll number 3, which just happens to do with COVID-19. I think we're all very curious as to, is everybody returning to work, or is everybody working from home until 2025? I know that some have, are on sort of a 50-50 schedule. Like some people come in Monday, Wednesday, Friday. Some come in, Tuesday, Thursday. That way people are not sitting adjacent to each other. So there's lots of different schools of thought on this. So. And the final poll is, if you could just rate Brian and his the value of the presentation. This is anonymous. Brian does not see this. So
I was going to ask if I could vote.
Yes, you cannot vote. Sorry, Brian. Let's see. One question came in. Have you heard from a customer whose life was saved because of your device? Interesting question. Brian, you want to take that one?
Yeah, I have a customer in Oklahoma, and I won't get into too many details, but they're a power generating company who called me after an event where they had a breaker blow up in a cubicle, using the system. And so, I don't know that I would, looking at the photos and some of the information I have on that particular incident, that the blast or the fire, the energy ratings or anything would have been, if you would have been in proximity, would there have been a fatality for sure? Who knows? But we definitely get some feedback every once in a while like that. And so, I think probably more interesting for me is, historically prior to remote racking, right? The guys that have been doing this by hand for lots and lots of years, I usually, when I'm out, on a customer side, I like to talk to those guys. Hey, what do you think? I was at a TVA facility, and there was a gentleman who, he was 10 feet from a buddy of his that was racking a breaker in, and it happened to be like a 3 or 4 high, where it was a little taller cabinet, and the breaker came completely out and almost decapitated the guy. Like it was a pretty terrible event. So I'm completely amazed as I travel around U.S. and Canada and internationally sometimes, the amount of injuries that have happened. So, even being someone who focuses on this conversation quite often, it seems like, 2 out of 10, 3 out of 10, have had an incident with a breaker. And those are typically owners of pretty big power systems, either generation, large industrial customers. So yeah. And then, I've had a few where, I got a call on a Good Friday one time where a customer had a breaker he couldn't get in and out. Like I had to help him over the phone with the manual controls to get a breaker back into a safe location because they were really worried about it potentially blowing up on them. So I think they had a mechanical failure, that kind of got them into that position. But we were able to, take 30, 45 minutes and eventually get them out safely without having to suit up and go back and, hand rack, which was great.
Couple more questions here. Is the Inolect racking device portable enough to move between outdoor switch gears?
Yeah, so I mean, our system has, we have some portable options that aren't shown in this particular presentation. We usually, when we're presenting like this, we don't go through the whole catalog of what we offer. And so I would say, if you're interested in that, I would be happy to, even set up a one-on-one with you and show you some more pictures and videos and things that we have of our more portable solutions. And so I would say, yeah, we have something that, this unit, a lot of people, because the tires are large enough, if you have packed gravel or, obviously cement, surfaces and elevators, some people have one unit and they can wheel it to every sub they have, right? If you've got a large, refinery or something where you may have 30, 40, 100 substations, there's some different options for that, and I'd love to discuss them with you, potentially individually.
Okay, that's a great answer, Brian. There's a good question here on the slide table of the remediation results. The last two columns, the headings were ST-RCC and LT-RCC. What do those mean?
Short and long-term recommendations. So I don't know if you guys can still, the poll is still up, and yeah. So obviously that table is an excerpt from a report that we do, and I don't know, it may be 30, 40 page type report, right? But typically we go through and say, okay, what is a primary maintenance switch? And we give a one line with kind of before and after the primary maintenance switch with the protection adjusted. Sometimes there's some TCC curves depending on if it's relevant. So we go through all of those particular techniques, and we give you, again, pros and cons, a budget number, kind of a turnkey budget number, because we'll do the engineering a lot of times with this. We'll also do the install, testing, commissioning, relay settings. But what happens is sometimes there's maybe a lesser cost, quicker solution that can be implemented that gets you, say if you're 100 calories, you may want to try to get under 40 as fast as you can, right? That's a common conversation, right? But then long term, you say, you know what, 40 is not, we're very safety conscious sort of organization. We want to go down to maybe where we can get our people in category 2 PPE or less. So now we need to be below 8 or 12 or whatever that number is. And so, depending on, what this table is designed to do is say, okay, what's the short-term consideration? What's the long-term, and basically what that is that's applying, like short-term may be remote racking, long-term may be one of the relay projects, right? Because it takes a longer duration to implement and things like that. So that's good question, and a good eye for whoever caught that quickly.
Here's another question. Is there a most common cause of an arc flash during the racking process?
I don't have any hard statistics or data on that. I would say one of the things that we probably got to get better in the electrical power business at doing is even when people do get hurt, a lot of the statistics are not reported historically with enough clarity about, okay, what exactly was the root cause? What was the failure mode? And it's no different from failures with circuit breakers. What I can tell you from my experience doing this over the last, 10 years or so, is that a lot of breakers get, cocked sideways, or they get rotated a little, horizontally in the cell a little bit. So I would say misalignment of breakers has caused a lot of grief over the years. Shutters not open and closing, I hear that quite a bit. Post outage, people in there doing work and maybe leaving a tool in the cell or cubicle. See that quite a bit. And then I think in general, I would say lack of maintenance is driving maybe some of those as well, and is its own contributor, right? Whether it's dust or carbon buildup or something like that. We probably could do a little better maintenance in our industries, across the board.
Okay, I think that's all we have. Thank you, everybody, for your participation and questions. And thank you, Brian, for your expertise.
Hey,
and we hope to see you guys at another webinar soon. Stay healthy.
Thanks, Brian. Great job. Thanks, everybody.
Thanks, everybody. Take care.